Yes, hello and welcome. Thanks everybody for coming over from Christian Stream. Great job. Little GitOps guide to the galaxy. Now we're going to be talking security on StackRox Office Hours. I'm joined by engineer at StackRox, Connor Gorman. Connor, you want to introduce yourself before I get through the agenda for the day?
Sure. Yeah. Nice to meet everyone. I'm Connor. I've worked at StackRox and now Red Hat for a little over 4 years. So kind of since the beginning of our current product cycle. And I'm a principal engineer at Red Hat and primarily working on the back end. So been around for a while, been through the evolution of Kubernetes as well. And so excited to talk, anything about security and containers and Kubernetes.
Awesome. Yeah, for those who don't know Chris Short, obviously if you're watching the channel, Chris Short is gone. Last day earlier this week. So we're having a little bit of Chris Short woes. That being said, I'm Mike Foster, standing in for him for StackRox Office Hours. A couple announcements. Next, the following months, we're not going to be doing the show on Thursday. It's going to be on Tuesday, same time. And today we're going to be discussing Kubernetes security, our top 10. Connor and I kind of put together a list of our top 10 things that I think people should be aware of. Some mitigation issues in the Kubernetes open source community that you can do, and then some more advanced features and more advanced solutions that you can look at as well. So with that being said, should we kick it off?
Let's do it.
All right. First one I think is a little bit of a layup, but we have disable public access as our number one sort of intro. I think it's kind of general. What do you think when you say disable public access? It's kind of Kubernetes private cluster, secure the API.
Yeah, exactly.
Thoughts?
I think one of the main things from the API server perspective is that there's surface area there, right? I mean, it's the way you control your cluster. And so, there's been a series of kind of attacks or DDoS attacks that happen against public API servers. I mean, famously, people have run crypto miners through exposed Kube API servers. That's probably the least malicious way that they could use it. And then, there was like the billion laughs YAML DDoS that could occur. So, those things happen. Those things exist in the wild. And, the Kubernetes security team does a really good job of triaging them and fixing them as fast as possible. But, just take your API server off the internet and, a whole variety of attacks are basically mitigated by that. And, that's a little bit of peace of mind. And, likewise, like with nodes and things like that, you can stick them in private clusters as well. For example, on GKE, they have private clusters and you can do stuff like that. And so that's always a good place to start, from just air gap your environments a little bit.
Mm-hmm. And some of the defaults that are installed in provider clusters, if you're unaware, might open you up to things like having, let's say default Nginx backgrounds or stuff like that hanging around if you're not sure. Always good to keep it private before you really understand what's going on.
Yeah, exactly. A lot of times, you'll just click a button and they're made to be super easy to use, right? Like, hey, give me a cluster, perfect. And, a lot of some of the security defaults are lost in that. And so, you got to be really careful about when you're actually building a production cluster, because what you see a lot is that a cluster that you were playing around with, doing a POC on or something like that, starts running more and more critical workloads. And then over time, now it's become a production cluster or a semi-production cluster. And so now you got to take a step back and make sure you're applying all the proper security controls.
Yeah, those baselines aren't necessarily properly there. It might work, but you really haven't operationalized it. It actually leads into the next point, which is implementing the least permissive role-based access control. And I think we can kind of assume that everybody has RBAC set up on their clusters now. This wasn't really an assumption that we could make 3 years ago, but it's safe to say that now, right? Any thoughts on, one, how to go about that, best practice, service accounts, things like that?
Yeah, I think, like we just mentioned, sometimes, your initial cluster makes it 3 years, right? And
yeah,
so
true.
Let's make sure you understand kind of like you do an audit of all your roles and role bindings and who's accessing your cluster. There's a couple of ways to do this. Within our product, we can show you basically all the access that you have. So you can look at a particular role and say, hey, are you a cluster owner? Do you have full access there? There's also a tool by Jordan Liggett wrote, which will parse audit logs and will kind of tell you, what people's access and what they've been using. And so there's some cool stuff out there to look at, parsing of audit logs and breaking that down. And so, yeah, just make sure you're always auditing that. And then, one of the best parts would be start with minimal access, and as people need it, slowly add it.
Yeah.
And then, of course, just the realities of running a production cluster is that sometimes you need break glass permissions. And so building that process in where you have kind of an audit cycle of, okay, I need cluster admin for XYZ. Okay, we got an approval, or I write a reason why, and that kind of like then can give me the access I need, right? Because there are those scenarios where, DevOps folks or other engineers do need kind of more privileged access. And so always account for that. Otherwise, there's going to be some service account sitting there that will grant that no matter what.
Yeah. And reality is always somewhere in the middle. So instead of being most permissive and working down, least and work up, sort of.
Yeah, exactly.
Making that
I think
analogy.
that's like a general theme with like Kubernetes and security, right? There's always this balance of you have folks who like are managing the cluster, administrating the cluster, and then you have people running applications, and there's going to be some level of debugging that you need to do on the cluster, right? Mm-hmm. And so how do you grant that access, and how do you make sure that like you're still providing the workflows of actually running the applications versus having a really hardened cluster?
Completely agree. Makes sense. And speaking of applications, container images. Now, not necessarily Kubernetes specific as the orchestration tool, but obviously our main workloads are running in containers. So managing vulnerabilities and providing a safe image. I assume when we talk about number 3, we mean base image as well as your own application. So
yeah,
some thoughts
definitely.
on that?
Yeah. So there's kind of been this concept for a while of also with even VMs, which is like the concept of like reverse uptime, right? Which is like you have an image, and if you just leave it running for a really long time, something that I've always liked to say is that like the number of vulns in an image only ever increases because the image is immutable. And so, in your base distribution, there'll only be more things found, right, over time, right? And so, your images naturally kind of drift towards less secure just based on the number of vulnerabilities found. And so constantly rebuilding your base images, all the distributions do a really nice job of constantly updating, fixing critical vulnerabilities. And so by just constantly rebuilding your images, even if your code hasn't changed, like you get a new base image, you get up-to-date packages that have fixed vulnerabilities, and then that can lead you to a much better place in terms of the vulnerability management within a particular image.
You said something there I think a lot of management teams don't like, but it's the vulnerabilities are never really going to go away, right? You're going to mitigate them, and then over time they're going to creep back up, and then you're going to mitigate them again. The challenge, I think, with vulnerabilities is finding that, what are the things that we want to mitigate with containers, right? What are the most impactful things? It's like, how do security teams make that decision?
Yeah, I think you have to look at Kubernetes gives you a lot of context about where things are running, how things are running, right? And so when you're looking at a vulnerability, many times a lot of them are not fixable, and they can vary in criticality, but I always like to look at things that you can actually do, right? Like what can you actually fix? And so we've got a lot of fixable vulnerabilities with like new patch versions. Those are the no-brainers in my opinion, right? Like let's go rebuild those images. Let's go redeploy them. Hopefully your services are, really robust and you can constantly roll them out, do CD. I know that's not always the case. And so you have to be cognizant of that, and then constantly update those. And then also if you can reduce the amount of packages you have, right, that just reduces your surface area. So if you have a bunch of extraneous packages in your images, let's try to reduce those. And that just like provides, kind of a slimmer workflow in case of vulnerability management.
Yeah. And once those containers get into the cluster, this kind of moves into the 4th point, managing secrets, environment variables, config maps, injecting various secrets and variables into your containers. What are your thoughts on securing that, the process for that? Because I always had an issue, especially once you get into teams. How do you manage secrets? How do you do it when there really was no encryption in Kubernetes, 3 or 4 years ago at the beginning, right? It was it just base 64 there for a while?
Yeah, exactly. So, I mean, going back to our RBAC point, that's like the first step. If you're using Kubernetes secrets, the first and foremost thing to audit is who has access to actually reading or listing the secrets. They're the same thing. And and when you do that, you do get them back as base 64. They are encrypted. You can encrypt them through like KMS and different methods. But when I get a YAML of a secret, I'll be able to read the secret, right? And so who has the ability to do that? Some folks don't even let read for secrets ever happen. Like you can only write secrets, and so if you want to roll them, you just have to rewrite over the top. This is a good workflow for like GitOps or different kind of like CD systems, like with the secret store, for example, which is a good example of that. But yeah, the secrets are one of the biggest challenges I think still kind of exists within the ecosystem, and there hasn't been like the perfect solution for any of that. So it's sort of an interesting area for sure.
Yeah, and I know that I think config maps became immutable as well. There's the option for that aspect, which some people don't really understand why config maps are immutable. But if you're injecting environment variables into your container, you kind of want, hey, we're going to roll out the next version of this container. We should probably make sure our config map that's going to be used to set up this container is also versioned with it. Little things like that I found really interesting.
Yeah, one thing I've seen is that they'll take some aspect of the config map and like hash it, and then you put it as the label on a pod. So then, like if the config map changes, like you can see which version of the config map should be running, because they do hot swap it underneath the mount, right? So you could be running a container and the config map could change, and so you're kind of in this weird state where it takes about a minute to propagate, and you're not sure, which config map is there, or does my service actually hot reload the configs? In some ways, just rolling out, like doing a rollout of the pods would be an easier way to guarantee that, okay, this config map is going to be mounted, because when you roll out the new pod, you will always get the most recent config map attached. And so that's kind of a way that some people mitigate the kind of uncertainty of, I modified a config map, did my change actually propagate?
Yeah, especially if you have any sort of CD process or anything like that with testing set up, you can always roll back, right, if your config map screws up. So you're not sitting there in limbo.
Yeah, exactly.
Definitely.
That's sort of like a Helm. I mean, that's like one of the benefits of something like Helm, for example. Or like, they're all in lockstep. Our operators in the OpenShift ecosystem, the similar concept, right? Like, you know exactly what you're getting all together at one time. So that's a big benefit of kind of like the bundled approach of deploying your service.
Mm-hmm. Now, had number 6, and by the way, anybody, people who are watching, feel free to put your questions, comments, things that are bugging you about security. Even you can be like, oh, security sucks, I like to be wide open. That's fine too. But we'd love to hear your feedback as we get into number 6, which I found is a sneaky security aspect that is often overlooked, is resource limits. I want to get your thoughts on that.
So yeah, this is sort of like a little bit contentious too, actually. So resource limits from, depending on what service you're running, really matter. So one aspect is that helps you provide the segmentation that you want between different services, right? You don't want one service to basically be poorly written or have a fork bomb or whatever, right? Like just suddenly fill up a node and then start having things be killed. I mean, the process is fairly good. It'll try to kill first the things that are overutilizing their resources and evict them. It's not a foolproof process by any means. And so I always think that setting resource limits are good, especially in like a multi-team environment where, like a lot of times people will look at resource limits and be like, this is your quota, and like, this is how much of the cluster that you're using. And like, even use like cost center billing to basically be like, here's how much you're costing us, because these are the resources that you're requiring. That puts some pressure back on the DevOps team and the team itself to optimize their code. So sometimes without that pressure of like, you need to set resource limits and constraints, there isn't as much reason to optimize your code for that reason, right? Because there's no direct impact on you. It's kind of like up to the infrastructure team. And that's a challenge for any infrastructure team. And another thing with resource limits, and I think security and availability go hand in hand a lot, which is resource limits allow, and having them be as low as possible, help you schedule things in your cluster, right?
Prioritize.
And so, exactly. And so you can schedule things more readily if you have proper resource limits and constraints set. So those are some of the main benefits I see from a security perspective.
Yeah, I think especially for stateful workloads, if you're setting, you have very strict limits on, and especially if you have a limit on your stateful workloads, but not on your other ones, they get the default for the namespace, but they also get evicted first because they don't have something that's supplied by the developer or the administrator there too, right? So there's a
Right.
little bit of assumption there, and there's some pretty cool features in Kubernetes where you can set it by namespace too. So as an administrator, you can kind of say, hey, you in this namespace, you're only allowed this much, work within it. Yeah, it's definitely, especially in multi-team clusters. I have seen, I'm curious what your thoughts, I've seen a lot of, let's say, micro sharding of clusters. I don't know if that's the correct term, but a lot of people using K3s or smaller clusters and using a cluster per team. Any thoughts on how you would set up resource limits for that, or like scaling of clusters? Just kind of curious what your thoughts are.
Yeah. So, I mean, from resource limits for those, you kind of have, I mean, there's a concept of like limit range, which will just automatically give a pod that has no resource, no resources set, like the basic resources. But actually, from a security perspective, I do like the smaller clusters, though you have to mitigate the challenge of like, where are my clusters, right? Which is something that happens. You know, you have 100 teams, now you have 100 clusters. And so you're always trying to find that balance as an organization of like, how many clusters do you have versus like running one large cluster, right? There's always going to be operational overhead between of running a cluster and some costs there, but you can really get the natural segmentation that you're looking for between teams by just having separate clusters, right? You know, team A isn't bleeding their service into team B because they're literally segmented, right?
Yeah.
And so
The challenge is setting that policy so the cluster comes pre-configured for that team, right, as they scale.
Right, exactly. And like you can allow each team to scale up their clusters, but you want to make sure that you have like unified tooling deployed in that cluster, right? And so
Yeah.
that's kind of as an infrastructure side, if you want to go that way, you have to be able to say, you know, speaking from personal experience, like with ACS, it's like, you know, you want to make sure that you have our secured cluster components and every single cluster that you deploy, right? And we've had a bunch of customers who have built that into their ops cycle. And so when they launch a new cluster, up to 300 or something clusters, right, then every single cluster gets these components and registers itself and is actively being secured like through security policy. But now, you know, you can really scale that out broadly as your organization grows.
Yeah. So clusters that get set up, they don't fall through the cracks, right? You're using some sort of like ACM for overall policy. I thought one of the coolest things that I had seen was through ACM, let's say you want to set up a developer specific cluster, you know, you can have the sensor set up for ACS, but just there's no admission controller. So it's like, oh, hey, developer started up a cluster. Okay, there it is. Right? I can see what they're doing, but there's no enforcement. So things like that, you can kind of mitigate stuff before it gets too far, let's say.
Yeah, exactly. And in that way too, you can see, oh, hey, this person created a load balancer in this cluster, right? And so we have a lot of insights into kind of the overall context of like what's going on in each cluster. And so you could see, oh, hey, they exposed this service over the internet. Like that's not within our security policy, or we haven't, you know, verified that it hasn't gone through a security review, right? And there's a lot of aspects like that where they make it really easy to use this stuff, expose it over the internet, make it publicly available, and maybe that's not exactly what you want. Maybe they didn't realize the risk in doing that, right? In terms of, hey, yeah, I was just testing this from my local laptop, and you know, making sure the proper security controls are there from each individual cluster and the services that are, you know, being publicly pushed. The worst situation is to have a prod service that you don't know about that's, you know, that's sitting out there on the internet.
And good thing we kind of got into that clusters. Number 7, we have segregate sensitive workloads. So there's a couple points here. I think we already talked about secrets a little bit, but implementing and monitoring traffic and setting baselines, separating through Kubernetes native tools like namespaces, right? I guess we'll start with that. Namespaces, properly setting them up, proper defaults. Thoughts on how to operationalize that specifically with teams?
Step 1, don't use the default namespace. There's actually some admission controllers and stuff that you can use that will say, don't let anything be deployed into the default namespace. I think it's sort of like, it's just someone ran kubectl and something showed up there is typically what happens. And so you really want to make sure everyone's, you know, in a proper namespace. I mean, the namespaces are super useful for some of the reasons we already outlined around like resourcing. for example, and seeing kind of the resource consumption of an individual namespace. But also, it's a really easy barrier to say this team's should not be able to talk to this team, or also like if you have a multi-tenant environment with different customers, right? Okay, customer A should not be able to talk to customer B, and how do I go verify that? And actually, I might jump over to the demo real quick, Foster.
Sure. Let's bring you in.
Cool. Sure. So this is our network graph. We're showing live traffic between different namespaces, right? And so this is kind of what's pretty interesting is like you want to create network policies that deny between namespaces, but there might be holes that you want to poke for things like monitoring, right? Like if you have a Prometheus operator running in your cluster, you want the monitoring to happen against your services. And so what you really want to do is break down and actually verify, even from an audit perspective, that customer A is not talking to customer B. So StackRox should not be talking to any of these other backends. It has nothing to do with them, right? And so like this is just a visual verification, at least, that you can do that. And then there's a lot of capabilities within the product that I probably won't go into right now around simulating network policies. The YAMLs are pretty difficult to write sometimes. And so you really want to look at them and say, okay, is this doing what I think it's doing? Is this actually going to block an active flow, right? Is this something that's actually being used? For example, this sensor is in a remote cluster, so there is no centralized component here. And it's going, you can see it reaching out to Google here at the bottom. That's because the central is in a different GKE cluster, right? It's in a different cluster. So that's where that one is, is flowing to, and you can see like the egress for it is going to Google. So, sometimes there are things that you miss or things you don't think about. You don't think about sensor reaching out externally if it's in a remote cluster, and this is just an easy way to like visually check that this is occurring. And then another really cool feature is to be able to look at the allowed connections, which kind of breaks down what things can talk to each other based on network policies, right? And so this will help
because
show
most
you,
of the time you're configuring network policies because you're trying to get your app up. And so you're playing around with the network policies just to get your app to work, and you have no clue. You just exposed everything else, right?
Right, exactly. Like maybe you just said, oh, everything can talk to this. And, depending on the service, you have different levels of connectivity and ingress or egress, right? So for example, this is our collector. This is an agent that runs on every node. It doesn't run a web server. It needs absolutely no ingress, right? So this is saying we'll allow 0 ingress flows based on the network policy we wrote. And based on the overall environment, we have 16 egress flows that will be allowed. So a lot of these other namespaces have no network policies set up. And so it can speak to all of these different pods in our cluster.
Very cool. Yeah, the visualization aspect of network policies, I don't think that can be understated. That's a huge time saver, not working through all those YAML files. And one of my favorite aspects of moving development to test clusters was to like just basically flick on and off network policies. Like you have some sort of network test, put in the test cluster, put a default deny on, see what happens or something like that, right? If you don't have anything in the dev cluster, or So it's this is awesome. Yeah, the flow's cool.
Yeah, I think like some of the aspects, things that I would do here is like maybe you have a default template for a namespace, and you say, okay, from the namespace of Prometheus operator will allow all connections, but then deny all the other ones, right? And then every namespace that you basically print will then have that default deny. And then, you just, if you need to poke holes later or someone's got a real use case, right, you can evaluate those at the time. If you can start this way, this is definitely the way to go. Now, it's very challenging if you've been using Kubernetes for 2 years and you're running a bunch of production services. How do you start applying this to a cluster that's already running without breaking a lot of things? And that's where looking at the active traffic and crafting network policies that align with that active traffic is really useful for folks who already have clusters up and running, but they haven't gotten to the network segmentation portion.
Yeah, the observability without enforcement, especially as a security tool, is extremely useful, right? You don't want to be shutting down anything that you haven't exactly verified as normal traffic. So very cool.
Exactly. Yeah. And when it comes to security in configuration, especially, I think it's always turn on violations, right? So like first you get visibility into something like network traffic. then you can start sending violations about things that violate that network traffic, right? That happens over time. We don't have the perfect view of the world. You could run Postgres and we could look at all the processes that run. But then when someone runs a backup and maybe the backup's by execing in and running some command, right? We don't want to kill that. We don't want to kill Postgres because of that, right?
Yeah.
So you want to see that. You want to say, okay, highlight anything that's outside of that band. Oh, actually, yeah, this is the backup. Good thing we didn't turn on enforcement right away. And then once you're very certain that we've seen everything that you're looking for, feel free to turn on enforcement or violations that go to even a higher notifier, right? Getting emailed about something is not like being paged at 2 a.m. for something. And so you kind of have all of these different tiering of kind of how you work through a security program.
Now, when you're scheduling all these notifiers, how would you group them? Does it get shot out by team, administrator? Let's say there's a network flow that violates some policy. You obviously don't want to blast it to everybody on Slack, right? For something like that. So,
right, exactly.
Is there on the platform? How would you manage something like that?
Yeah, so you can annotate your pods with specific aspects that you'd like to route through. So you can say, okay,
Gotcha.
to this Slack webhook, or and that would be done on a pod basis or a deployment basis. The same thing with email, right? A lot of times people will have an owner field of here's the team you should email about some of these issues. And then of course you have levels of when you'd want to send these notifications and how serious and the relative severity of them, right? And so you want to separate from there. So someone using latest tag, okay, maybe that's a very low severity. And then someone with a really critical vulnerability that's fixable. Hey, someone needs to jump on this. This goes to a PagerDuty, for example.
Pretty cool. That's awesome. Yeah, there's honestly, I feel like Kubernetes also favors the meticulous, right, in that aspect. You have some applications in a namespace, everything's going to revolve around those labels and annotations and how you separate your workloads. So I always used to tell people getting the namespace set up for your application is that core base that you're going to build all your policies off of, right?
Awesome. Yeah, exactly. Some namespaces are just naturally more sensitive than others, right? You have a namespace for the payments team, right? This is going to be a much more stringent from a security perspective than a machine learning thing that's not namespace that's never on the internet, right? It never exposed, has no load balancer, and so there's kind of a large variety of different constraints that you have, and namespaces that allow you to also within our platform say, oh yeah, these namespaces have these rules. Even this cluster in these namespaces have these rules, and these other namespaces don't have these rules, or here's what we care about and here's what we care about. So you can kind of separate that by team and namespace.
Yeah, and if you do it right, you don't have the teams bickering with each other over resources. I think that's why we got to sharding of clusters. It's just, hey, here's your cluster, but then you get cluster sprawl. So bringing that all together is interesting. Speaking of which, audit logging is coming up next. Enabling audit logging. I think by default, most clusters nowadays have, and most cloud services have some sort of audit logging functionality. I think the biggest issue is, what are you looking for? How do you monitor it? And what are the things to look for, right? Because do you look for a bunch of API requests? Are you looking for, kubectl execs? What are the main things we need to look for?
Right. Yeah, I think anything that's directly interacting with pods is kind of especially those execs or port forwards, right? Those are things that I would be concerned about. And then also typically if you have an RBAC setup, right, you don't want a lot of people to run kubectl commands against your cluster. I think, when you're really at the production level, you don't want systems like that or people necessarily directly interacting with your cluster unless you have to, right? Yeah. And so that's the stuff you want to log. And that's the stuff you want to look out for. And we recognize this for sure because, port forwards, yeah, you have a direct local host to a server, right? Potentially bypassing different things or different firewalls or load balancers. And then likewise with execs, right? You're in the pod. You could have as much security as you want, but if someone's inside your container and, can cat your database files or look at your database files, there's a limited things you can do from that perspective. And so actually, if you want to flip back real quick, I actually really love this feature that we ended up building, and we pipe it through actually the init controller. So so you can kind of default deny them as well. I'll go to the violations here. I'm on my terminal, but I'm just port forwarding to, or sorry, execing into one of the StackRox pods on this cluster.
Nice. Can you zoom in a little bit? Do you mind?
Oh yeah, sure.
On the dashboard? Perfect.
Didn't really do too much, kind of automatically shifted there, but right. So I'll exec into the sensor pod, and like all live demos, slightly stressful. Oh,
Whoa.
cool. So yeah,
That's
right.
cool.
So it just pops right up. So you can see that, okay, we had a Kubernetes action, we exec into a pod. And actually, if you break it down, you can see that it was me that I did this, and like what group I'm a part of. So, okay, an authenticated user did exec into this pod. What you can do is kind of trace these breadcrumbs that if we go to the risk page and look at, for example, the deployment, which is sensor in this case, there's 2 of them, but we can see that this one actually found an anomalous process. And I go to process discovery here, and it's SH, right? And so I just had open a bin SH there. Let's see what I can do here. I reload this real quick. See if we picked up all my other stuff that I was doing. Yep. So I ran ls, right? So, right, you can kind of like, there's some breadcrumbs to follow here in terms of what processes were run. And this red indicates that we found that it's anomalous, that we basically have been running this container for quite a while, or this pod for quite a while, and we've only ever seen this Kubernetes sensor. It's a Go binary. It's very easy to tell that this is the only thing that should be running. And then these are the other processes that came, after we've baselined it, and we're like, hey, these are new, these are strange. Now, sometimes this happens, or things run periodically, and you can just add them to the baseline, and they won't show up as anomalous anymore. In this case, I'll leave them because they are anomalous because I exec in. So you can kind of immediately see that. And then we also have the ability for everything that you can highlight through alerts, you can also reject them through the admission controller. So if I change that policy, I could make it reject my exec.
Now, when it rejects it, does it delete the pod?
So from an admission controller perspective, you can, like, you're just blocked. Like, you just get a report back to kubectl that your action got blocked. But if you have other runtime data around processes, for example, that's actually running, right? The pod may be already running, and then you see some anomalous processes. There is an option on the enforcement to kill the pod, and we'll just kill that through Kubernetes. We'll say, hey, we saw something strange. Let's just kill that pod, and you can see if it happens again. Again, always be very careful with this, right? You don't want someone to exec into a container to do some debugging or something, and just, we'd immediately kill that pod. And depending on, it may be a little bit more sensitive than others. And so those are some of the concerns just around that stringent enforcement, but we'll always show you the violation as well. And so, you can pipe those to, some more like incident response.
Yeah. And having the context of who's doing it obviously is a huge factor in that decision. But I mean, just blocking the action alone. And then if you're able to delete a pod, if you do have a highly available deployment, deleting a specific pod or enforcing that rule should be okay, right? It really, you obviously don't want to set that as the standard, but and you hope that people have set up their deployment correctly. But deleting a pod, there's no massive impact, right? It's a little bit different from like wiping a whole workload for a security issue, right?
Yeah, exactly.
So
those are kind of like the
flexibility
main
there.
Yeah, and that's what I actually really like about the admission controller on creates, right? Just in general, is that you're usually not changing the state of the world, right? Like, someone's trying to create a new deployment, you can be a little bit more stringent about, okay, what hits your cluster at that point, because it's not currently running, and so it's kind of just staying in the same state that it is. When we run admission controller on updates, for example, that one's a little bit scarier, right? Because you could be running, just critical updates or image update, but now you're violating some policy, and then that could be rejected at that point. And so you're still staying in the same state, but it's a little bit more risky from that perspective, in my opinion.
Definitely. Yeah, we got Kevin. I'll post all 10 in the chat at the end. We're just getting on to 9, so 2 minutes, and I'll just copy and paste the whole list that we made. You kind of mentioned it, touched on it a little bit, but that providing a secure software development process. Now, this might be the most vague out of all of them, I think, because everybody has a different software development process. Real quick, top things in a container build to deployment in Kubernetes. What are your thoughts?
Yeah. So let's start with the source code,
Yeah.
right? Like you always have to have some sort of like source code scanning, linters, just general hygiene around your code, right? The earlier you can find something, the better.
Mhm.
Then you take that code and you put it in an image, right? And then now you still have the same sort of hygiene around that image. Let's make sure you're scanning your base image. Things are up to date. The number of times I've seen something like Alpine 3.0 in someone's environment, right? And you're like,
Yeah.
man, I have to go back and look how old that is, are things that you want to, really adjust quickly. Make sure you're scanning your actual code too, Java applications and everything. And then, when you're crafting your deployment YAMLs, right, it's like, what does my service actually need? And how do I validate that, right? So, does this thing need to run as privileged, right? Do I need these capabilities, right? Do I need like netraw, which is a Linux capability that's by default available, but almost no one needs to do transparent proxying, I think is what that allows you to do. So very few situations where it's actually necessary. And then, setting your users and UIDs and GIDs and all of that, like kind of fun stuff. Like that's kind of the nuts and bolts of like, how do I actually run this service, and making sure that you're not running everything as root is kind of like a really good place to start with that.
Mm-hmm. Yeah, I'd almost recommend security teams, if there's some sort of template, like you can take YAML files, right? And just take one that's been applied to a cluster, pull it out, set some defaults, and give it to the development team and say, hey, fill it out, right? Like, let me know what's going on in your process. And if you don't know, you have a month or two to get back to me on it, right? Just for teams that are just starting, I think that there needs to be a little bit of communication there about what's expected. Thanks for bringing that up, because I actually skipped number 3. I started talking about secrets when we should have been talking about security contexts. I think that was probably the biggest thing, especially with pod security policies getting deprecated. You touched on it: Linux capabilities, UID, GIDs, dropping privileges. What else for security contexts should we get?
Yeah, I think those are some of the main ones. I mean, if you can use some of the more advanced options there, you have like seccomp or SE Linux. If you can use those, then that's great. I know those can provide their own challenges as well. But those are kind of like just the places to start from the security context perspective. I think the user one is just big. That just helps, just move you out of root immediately.
Yeah.
One of the ones that's maybe not in the security context itself, but I actually really like, is the read-only root file system. So a lot of general attacks, if you look at Metasploit, for example, a lot of the attacks go to /temp because that has been traditionally writable on every file system.
Just dump everything in there and
forever. And there's a lot of applications that assume that /temp is writable. But for example, we're running a sensor, it's a Go binary. It doesn't write anything, right? And so, okay, how can I utilize that fact to just reduce the service area of like anyone running an attack against our container, which is, I'll set the entire file system read only. And if you try to drop a payload, you just get rejected, right? And so that is like a huge way you can reduce your attack surface. And it can be complicated to run. I mean, sometimes, you write lock files or things out, but if you can analyze that and just put even like the volume there at those locations through Kubernetes, Docker volumes don't work exactly.
yeah,
They don't
config
get
map
passed
or something
through
like that.
correctly. Yeah, but you can create a volume like just a temp volume in Kubernetes and put it at that spot, and the rest of your file system can be read only. And so even that provides a lot of protection from that standpoint.
Nice. Yeah, and you mentioned SE Linux. I found one of the better workflows. Security team tends to be, let's say security team handles SE Linux. If you can hand off the deployment file with the list of permissions of user IDs and capabilities you need, you can let the security team figure out a lot of those aspects for SE Linux on the host without even having to get into that aspect in your Kubernetes clusters. So yeah, it's just sizing up what responsibilities are where, and having that communication, I think, is one of the biggest challenges. All right.
So this kind of bleeds with 4
ahead.
and 10, right? So 4 is like pod security policies, and 10 is configure admission controllers, right?
Yeah.
As pod security policies get deprecated, right? I think they are basically going to be replaced with admission controllers, right? And so
Yep, it's an admission controller, I believe, and I think there's 3 in monitor, watch, enforce? There's like a
Yeah.
least permissive, medium permissive, and very strict.
Right.
Yeah.
So, the admission controllers that, things that you can use as pod security policies go away. Our platform has admission controller. Like things like OPA gatekeeper in the community, Keyverno, different things like that to be able to provide some of this context here around security and providing that in a generic way. So I think those are kind of one of the main ways that this will be, you'll do pod security policies, I guess, is kind of replacing them with kind of like, also what's nice is that they're a little bit more generic as well, right? Pod security policies are pretty tightly confined to very specific aspects of your pod, and admission controllers can check a large variety of things just around configuration.
Yeah, sorry to anybody watching. The copy paste into Restream is not great. So that's just a big word soup right there, but I'll try to format it a little bit. Yeah, I understand why PSP deprecating is a conversation. We're really still talking about security context. It's just how do we wrap a policy around it so we can actually operationalize that, right? So it starts with just making sure that the security contexts are working for each application and that teams are caring about that. And it makes the application of whether it be PSPs, admission controller, OPA, OPA, Keyverno makes it so much easier, right? They're just layers of abstraction built on top to help you scale.
Yeah, exactly. You're just, it's just a nice method of enforcing that, hey, you guys are using the right things, or that you're not running these things as root, or at least you have the exception, or like we can audit what's going into the cluster. Because I think one thing that's happening with Kubernetes in general is that there's a lot of like deployment responsibilities now on developers and developer teams. And so, in a lot of ways, I view it as application teams are responsibilities to write and ship applications. And of course, those should be secure, but that might not be their forte or their area of expertise. And so you kind of need these guide rails and guardrails to say, hey, this is how you should deploy this, or you probably shouldn't run this as root. Is there a good reason? And a lot of times they'll be like, oh no, we can run it as any other user. Like, just let me know how to do it, and we'll just run it as, some other UID.
Yeah. Yeah. And that conversation works a lot better than, hey, we've had no policy. Let's implement these policies across all our clusters really quickly without any information about their deployments. That'll be a lot of friction that you're creating with something like that. So yeah, 100%. That's our top 10. I will try to post a better comment in Restream for anybody watching. Kevin, hopefully that helped you with the notes. Probably made more work for you, but there's the top 10. We did have a couple hot topics. What's next? KubeCon was last week. For those who missed it, all the videos are going to be available online, I think, in the coming weeks. They did a great job with the hybrid setup. It's definitely extremely challenging. I liked it at home because I got to, instead of, setting your schedule where you have to go to all the events, like you could just binge watch a bunch. But want to talk about, hot things. Supply chain security was a huge conversation, and specifically container image signing and verification, cosign, building and signing images with Podman. Wanted to get your thoughts on maybe proper implementation. I don't think it's a great tool. It's another tool in the security arsenal. I don't think it's the silver bullet that people think it is. What are your thoughts?
Yeah, I think that's super true. I think it's a really cool tool, and I think that it does definitely have like good security implications, right? That like, kind of verifying things that are going into your registry and being able to attest where they came from. Now, this sort of happened with SolarWinds, right? Which is I think a big reason why a lot of these conversations have kind of come to the forefront. But if the supply chain itself is compromised, then like you could still sign binaries and things that have issues, right? So it doesn't fix all of the issues, but definitely addresses like malicious images in your registry that didn't come from where you think they came from. Yeah. And so I think that's
like injection through init containers or something like that, right? If your workload is not supposed to have anything added to it, something happened during the init process, you'd be able to see that, right?
Yeah, exactly. And so,
but those can also be caught with existing runtime setups, depending on what you're doing, right?
Yeah, absolutely. I mean, I think the more mitigating controls that you have, the better. And so if you, a combination of those two things is probably best, right? I think a lot of times, we like to look at, security is like, just a multi-layer process, right? And there's a bunch of good tools out there and products out there that help with all of that. And so sometimes, it's not one product is your silver bullet, right? And so you're kind of, like you said, an arsenal. It's kind of like, you have a bunch of these things layered together, and and you can like utilize the best of each. And so I'm a pretty big proponent of that.
Yeah, and one of the best, probably in terms of operationalizing it, one of the best things is you can do it with the security team can just implement it. Like most likely your developers have set up a container build process that you just basically need to add on to that to sign and verify it, and you can build it into your CI process without a lot of, let's say, friction between teams, because that existing CI system is already there, right?
Right. Yeah, I agree with that too. It's like, it should be fairly easy to go implement these things. And the final part is like, okay, the actual verification process, which is interesting as well, right? It's like you have to go. Now the last part is, of course, when you go deploy these things, let's go verify that this is what you think it is, and that verifying the image that you're actually pulling is in fact signed, right?
Yeah.
So.
Exactly. We talked a little bit onto the next hot topic. We talked a little bit about ephemeral containers. Kubernetes K8's 1.22, it moves into alpha stage. Is this going to change some security workflows? So like ACS, which had kubectl exec notifications, I think that still remains there. Do we need extra security around ephemeral containers too?
I mean, I think it's another thing to watch, right? Like if someone's launching an ephemeral container, that's something that's kind of out of the norm, right? I expect this to not be launched all the time. From a security perspective, I actually think it's a plus because you can build images that are way slimmer now. A lot of times you'd build an image with maybe some network tooling in it, just in case you needed to like do DNS lookups to ensure that like something is working, right? Or like, why can't this namespace talk to this namespace? I think debugging network policies is a really hot topic there, where these two things can't talk to each other. You're trying to figure out why. You really want to run a curl between these two services and be like, what's going on? But you may not want curl in your main image, your main application that you're running, because that could be used by an attacker, for example, to download a payload. So an ephemeral container, right, is just you have all your debugging tools all set up there, and the whole point of something that's ephemeral is that it doesn't run that long, and that way you can kind of run your debugging and tear it down and move on. I think they're missing the tear down part right now. I think it will stay in the pod for the lifetime of the pod. Last I looked, but
from a development standpoint, it seems to be the most applicable. Right? You can tell all the developers in your team, hey, here's an image with every single tool that all of these teams need. You guys can all use it to check your application. Just run this one thing, but you take everything else out of your image that you would normally use, and we're alerting on this in production, right? Sort of thing.
Yeah, exactly. It gives them a way to respond to the question of like, how do I debug my container in prod then, right? And it's like, here's this formula of how you do it, and please remove everything else from your image because we're literally giving you an image that can do this, right? And so it's kind of like a bargaining chip, I would say, because I think debugging things in production is always difficult, and so this at least gives you kind of a way that you can have application teams use this.
Very true. All right, last topic. Validating true security threats and metrics. And touch on this a little bit with vulnerabilities. Vulnerabilities never really go away. How do you triage it? Another aspect is, how do you validate that the security choices that you're making are helpful to your overall posture? What does that look like? And where are the security tools going in terms of measuring that? 'Cause, like, measuring risk is always a tough conversation, right?
Yeah. No, yeah, I think, that's a really good question. I don't have all of the answers, unfortunately.
Yeah, I don't think anybody does.
But yeah, I think a lot of the stuff around configuration and really trying to scope it down as much as possible is really useful. I mean, there's always some edge cases here and there where things need special privileges. I think when you think about measuring risk in a Kubernetes environment, you have a lot more data, right? And like you can start utilizing some of that data to really influence your decision. So you have things like, you have a vulnerability and you have the vectors for it, if it has a network attack vector, for example, like, is it exposed on a load balancer? Do you have network policies set up in that namespace to deny access to it? It's like, how do I quantify what really has a lot of risk, right? It's like something that's a severe issue that's exposed over the internet. It's like, yeah, I want to go look at this, right? And I want to go try to address this issue as fast as possible. Yeah. Another aspect, something that we just shipped, it's not in this demo, unfortunately, is around the concept of like active vulnerabilities. And so how can you see what is actually running? Is this vulnerability potentially exploitable because there's a process that's using this library, for example? And so that helps you provide even more context around this vulnerability and its like potential to be exploited. Is it in a process that's running? In that case, I'm like, hey, like, wow, we should go look at this immediately.
And probably in how many containers too, right? Like if it's a base image issue and that base image is being used across the cluster, that's a high impact, right? It's in how many different running containers.
Right, exactly. And sometimes, you wonder because there's different things in the base image that you never use, or you may not know you're using, or you honestly just never use. Like sometimes they come with Python, for example. Like we write Go applications, we never call anything in Python. And so it's like, how risky is this Python vuln if we never call Python ever, right? And so you can kind of drop the risk of some vulnerabilities and raise up the other ones based on how active they are.
Very, very, very true. And that's, to some extent, that requires a little bit of user input too, right? And people being aware of the applications that they're running.
Right. So this is kind of the value of having a whole runtime component of our product as well, right? Is like where you can look at what are you actually doing, right? If you're thinking about network flows, for example, it's like, okay, how much network flow traffic have I actually stopped? How many violations around networking have I actually created that are of value, right? Looking at, one thing that we could look at in the future or something is around file rights and whether or not you could create things read-only file system or influencing configuration based on what's actually running, right? Because I think the concept of knowing everything before you deploy an application is just a pretty challenging situation, especially if you're deploying something off the shelf. I mean, I run Nginx is always the container that I use. I kubectl run in Nginx. I still can't tell you all the processes that run as a part of that, or what files are written, or what network connectivity is used. And so, or like what port is opened by default.
I think the fact that Rancher's new release, they dropped the Nginx default backend. I was like, yeah, it's the defaults. I think that as Kubernetes gets more mature, we're starting to realize what defaults are useful, but that's a little funny. Nginx. All right,
it's always the default test container. Yeah.
Yeah, it is, and for good reason. It seems to always work, right? Yeah. That was always the huge benefit when starting with Kubernetes. It's like, if I take this Helm chart and it works the first time, I'm going to stick with it for a while until somebody tells me not to. But yeah, that's awesome. Anything else that you're looking forward to? Security space, changes in Kubernetes?
Not too much. I mean, I think there's always a lot of interesting movement in the community. I'm curious to see what the next sort of, they're not RFEs, but the kind of like improvements in the KIPs, I think that they are, the enhancements, or KEPs, sorry. Really curious to see what people have there and what people want to move forward, especially as Kubernetes scales and, needs to get more scalable, and there's larger clusters that are being created. And so I think there's always going to be interesting use cases and stuff that pop out of that.
Nice. Yeah, if anybody is checking this out and wants to talk about a use case, wants to tell us to test something out, you can ping us StackRox.io. Go to the StackRox.io community, and there's some emails, bunch of docs, and some communication stuff. Shoot me an email, and I'd be happy to chat about it on the future streams. Connor, thanks for coming on and walking us through the top 10. Hopefully we'll have you on again soon. Possible?
Yeah, sure. Anytime. Yeah, it's super fun.
Nice. Anybody else watching, have a good, I guess I can say weekend, right? It's Thursday. We say good weekend. Hopefully people get the day off. Yeah. Awesome. Thanks for joining. Thanks for listening to the top 10. Stay safe, stay secure, and have fun out there.